Okay, so this is from your notes, talking about how we can evaluate multivariable functions. So one thing that I want to point out is the entire semester I've been giving you kind of not so real world problems because we've only been talking about functions of a single variable. But as you'll see soon, most functions are multiple variables. The one function that was not of a single variable was inventory cost because it relied on both the items that you had per order and also the number of orders per year, right? So that was a multivariable function, multi meaning more than one. Okay, so here's an example I like to give. Car insurance is a multivariable function. What you pay for your car insurance if you were to go into State Farm would be based on a variety of things. The age of your car, for example, your driving record or history, your grades if you're a student, the driver's age, and then there's a host of other things that factor into what you're going to end up paying. So again, this is one example of a multivariable function. Another example, if you were to go to Walmart or Sears, then that profit would not just be based on tires, right? Sears sells a variety of things. So the profit would be based on tires, for example, and shirts and pieces of jewelry and perhaps book bags and a variety of other things. And even these can be broken down into various categories, like tires might be from Michelin or from somewhere else, and there are different brands of shirts that would dictate what your profit is going to be. So another example of multivariable function. Okay, the one that I'm going to kind of talk about more than the others in this class is wind chill. And wind chill is basically what it feels like outside. It's not the actual wind speed only. Okay, so wind speed does factor into what it feels like, but the temperature and the wind speed both contribute to the feeling, the degree temperature that you feel that it is. Okay, so then the question is, what if you were asked to evaluate a multivariable function? So this says f of x, y is 3x squared minus 4x plus 7. And here I said find f of 1, 2. Then it's the plug and chug. The 1 goes in for the x because it's in the x position. The 2 goes in for the y. So this is 3 times 1 squared minus 4 times 2 plus 7. Right, here's another example. G of x, y, z is 5x e to the 1 minus 2yz. So let's see, 3 goes in for the x, the 1 goes in for the y, the 4 goes in for the z. They're not always in the order that they are substituted, but in this case they just happen to be. So that's it. So all I've asked you to do for that first homework set is just evaluate multivariable functions.